Welcome back. Hopefully, you enjoyed the first section of this workshop that refreshed our basic applications and usage of the large language models. And hopefully, you had a chance to recap the three different approaches, including the comparison of the strengths and weaknesses of each in the article. Basically, a combination of those approaches might be the best because different tasks might suitable for different approaches. Now, let's move to the second part, which focus on this newest development on large language model application, which is the agentic approach. Let's define what is a LLM agent first. It is a AI system. AI here just means it can automatically complete a task based on some input. So it is a model that can perform certain tasks given by the user. So this type of automatic system has a mechanism called large language model that can understand different natural language type of input and generate a output depending on the request sent by the user. So you can deem it as a brain, just like our human brain, where we put our senses, our visual, the audio, and our touches of different sensory data into our brain and process there in a black box. We don't know yet about the specific mechanism, although like LLM, we may know in a high level what it does to process different information, and then as output, which are our thoughts, our expression, our communication, our writing. A lot of it is the thinking process and the recognition and analyzing the different data into our brain, and we can generate and complete tasks based on those data received. So LLM here is like a brain. It can reason through complex problems like mathematical problems, coding problems. It can analyze the input and analyze the user's requests, put some thinking process in it, plan tasks. And this is the definitive distinction between a agent versus a regular large language model based AI, because a general LLM AI may complete tasks based on some input, but it may not have the ability to plan well, to do complex reasoning, which are required for complicated mathematical or coding tasks, or a task that needs multiple steps to complete. So by doing the planning and reasoning in each of the different steps, it calls a tool that's necessary for completing that specific task. For example, if it's solving a mathematical problem, it involves a few steps, and each step it may call a Python or a calculator to help it complete the full end goal. So from the start to the end, there are a few steps that it needs to call external tools to complete. Another example might be finding a route from one place to another place. So it might call Google Map. It might also call a Google search for different latest information, or it might call your preferred way of commuting, etc. On the right side of this slide is a visual display of the key components that's essential to define a LLM agent. So it has prompts as the input, which is users' requests. It has a memory that is connected to the given history of the conversation or the context of the computer that the agent is hosted on. So it's beyond the prompt as it incorporates local context as well. So agent might need access to your computer files, for example, or some other access. This is what make agent much more powerful than a regular LLM AI product because those regular ones may only have access to certain files you uploaded and the prompts you entered in the chatbots. But the agent is installed in your computer and it will ask your permission to access a few different abilities. For example, to control your screen, to log in your email and send emails, and to manage your files, to read your files and write and revise those files, etc. So it has the memory, which is the full computer you have. That you host this agent. And then, as we mentioned before, another very definitive characteristic of agent is it has the ability to reason and to plan. So planning is the key process that differentiates agent with other regular AI. You may still select a thinking model and it can reason in that way, but here is a different level of planning because, for example, if you ask this agent to book flight for you, the planning is much more complicated than a regular thinking or reasoning to answer a question you pose. So to answer a question, it might use different steps to search, to verify the sources, so it's verifiable, etc., to give you an answer. But a planning agent means from collecting flight information to synthesizing maybe bank information, your different discount information, etc., and to access the platform to book the flight ticket for you. A lot of different access and a lot of different steps that each step contains a planning process. So in the whole, it's a multi-layer planning process that requires heavy reasoning and thinking. So those is the planning module. And in that planning process, to achieve each step, it calls a lot of different tools that might be more diverse and a variety of those tools than a regular AI model that might only use tools like Google search or image generation, those tools, which are frequently used and helpful, but here are a lot of API calls connecting to different applications like Google Map or another website, so it can use and access just like human does. So this agentic approach is the newest development and super powerful. And in this section, we're going to hopefully dive into and understand the different use cases and how institutional researchers can embed a agentic workflow and to learn to do that. So first of all, when we hear such a powerful tool, like LLM, it is both exciting and also intimidating because it's so new, and the field is still exploring it. As the field is figuring out what it is, some of the pioneers have explored agentic workflow, but it's not necessarily for each task. There is a saying in Chinese, which means if you are going to kill a kitchen, you do not need to use a knife that's specific for ox and cows. So this is a different level of model token usage and a different level of requirement for your GPU and storage. If a task is simple enough, you do not need to cost so much token and setup for agent workflow. So the key point on this slide is to first identify what type of task you have and choose the appropriate approach that's the most efficient in terms of cost efficiency and also time efficiency and everything that's good enough for your task. Agentic approach might not be the prior or the top one just because of its high performance. For example, there are two tasks that I roughly split them off. One is one-off tasks that is just one shot, simple, single step, although the single step may contain some thinking process that you think it might be multi-step. But here, the step is more like a rough to one answer type of task that has straightforward prompts. The process would be quick. So those type of tasks, you might still use the previous approaches we mentioned, which is chatbots. Either you are subscribing a chatbot interface or you're using an API to call a large language model, or you are deploying a local model, but it's still straightforward prompts interacting like a chatbot with the model to request some outputs. But on the other hand, there are, as we mentioned, a few more complicated tasks that involves multi-step workflows. For institutional research, the most popular and classic example would be a data analysis. So a data analysis is not a single step because it involves, for example, reading the data, reading the different columns. They maybe take counts of different columns and then visualize it. And maybe you need an interpretation of the visualization. Sometimes you may need to call a historical file to make a table that compares the current data with previous ones. And also maybe you need to fetch data from Tableau. You may need to collect additional data to supplement the current data for different comparisons and benchmarking. And then once you get those data, apart from visualizing it, you might apply different data modeling, statistical, descriptive, or significant difference testing, a lot of different data science methods and tools. And in the end, you need to produce some visualization and reports, including slides or traditional reports or interactive dashboards. So this is a full workflow for a full data analysis project that is indeed multi-step and oftentimes chained steps that involves much more complicated multi-layer reasoning and thinking that needs a lot of extra tools to be called, not only mathematical ones, but also the access to your files locally or searching different data on the web. So that's a very complicated task to do that involves multi-step workflow, and that's the one that makes sense to use LLM agent. An agent is still developing. Someday it may easily be called using a start-to-end pipeline that the user only need to input, supply the necessary files and context and prompts, and then it will be a one-stop place to produce a end result. But today, as we can see, it's still a hard task for the LLM to do. And human and data analyst are thus not replaced yet by those agents. But we will discuss a little bit more on the future from my perspective in the end of this session, and to welcome any thoughts from the audience as well and comments as well. So let's dive a little bit deeper to discuss this different type of tasks. The one-off simple task, the main job for you is like what we discussed in the 3 approaches. You need to choose the right tool for each specific task. We've talked about the different chatbots, the Gemini, ChatGPT, Claude. Those are general chatbots. But if you have a specific task like making slides or presentation, Notebook LM might for summarizing and making podcast. Manus might be making a presentation slides. So there are different specific fine-tuned tools for you there that might perform better than a general tool. So for one-off simple task, that's the first strategy or tip for you. Choose the right tool for each specific task. And you may compare outputs across different model providers and different softwares as well. For example, comparing Gamma versus Manus to see how the slides look like and how much hallucination it has, etc., how strictly it follows your prompt, how many times you need to adjust the outputs so that you can have a better idea of which software or tool might be the best for your specific task. And then some of you may question prompt engineering because prompt engineering might mean different things to different people. But what I mean here is to refine your prompt to include all the necessary context and instruction, and also draft your prompt carefully to include the things you don't want and the things you do want. And sometimes this is a recursive process and improves each time. Once you know the output, you know where it did not well, and then you will next time add in your prompt the issue that you want the LLM output to avoid. So this is the tip moment here, the strategy moment to share with you, like what we already discussed in the chatbot usage and the integrated AI software usage. You may compare and also write your prompt carefully to achieve the best result. And then what I want to highlight here is beyond using those chatbots, choosing different softwares and tools, we also have the option to use API. This is because, first of all, maybe for me, the most important consideration is the cost. If you are using different software, if you are subscribing, for example, a general chatbots, it's usually $20 per month. But actually, for IR tasks, we do not need so much token. And sometimes if we use API instead, it is charged by our usage and it's typically lower than subscribing one or multiple different specific or general chatbots. So that's the first kind of from the perspective of the costs. The second one, as I listed here, is more of a documentation purpose. You can use API and reuse it and also scale your workflow because you can open multiple conversations at the same time and run the API call on different tasks at once. Later, I'll show you what I mean in a demonstration. But here is the comparison for the additional benefit you will get if you are using API. The cost is, first of all, free tier available is actually also applicable for web interface, the chatbots. If you don't pay, you can still use the free version. That is a limit on thinking model and pro model, but the fast, if you are using Gemini, I'm talking in Gemini terms here. So you still have the free tier available, but if you are using a paid API, so API also have a free tier, but if you are using a paid API, just like your subscribed version, your data would not be used to train the data, to train the model. So this is the similarity, but more is about the differences and advantages of using API for a scalable workflow and for full documentation purpose, and also cost effective if you do want to compare it with the subscription strictly. And then now we can start our first exercise that involves this API approach. Please go to the worksheet again and go to activity 3. I chose Google AI Studio for this exercise, but I want to acknowledge that there are much more sophisticated API usage application. If you are a Python user, you already installed VS Code or another interactive environment for writing code, you can actually directly writing code to call a API. But this is a general session for people who may not have any coding background. So Google AI Studio provide a web interface and actually a coding-free version to use model actually based on API. Although the interface, as you will find out, looks a lot like a chatbot, but it's actually based on API. And actually, API is not a very special thing. It's just a different way to call the model. So instead of using a web interface that you cannot see a API being called, you just have this API calling process more transparent now. So in the chatbot, you're still calling the API. It's just hidden in the background and you cannot adjust anything. So once you are on the worksheet, click activity 3 and follow the 3 steps there. The links is already embedded in the worksheet and you can click and start the 10-minute exercise now. And I'll stop. And once this become 0, the time is up, we will move to the second part of the activity, which is the local deployment. But now first, let's focus on this, and I'll also make a transition before we go to part 2. But if you finished early, feel free to go to part 2 on your own. Welcome back. Hopefully you find it's very easy to start this, and you find it's a lot similar to the Gemini chatbot you're using. And then why we're using this if it's so similar to the chatbot. The advantage of using Google AI Studio, which have explicit API set up, is this. As you can see on the right side of the slide, I took a screenshot of the interface that you can see on the Google AI Studio, but you cannot see on a Gemini.ai chatbot. This is because these are all the different customization you can use. And later you will have opportunity if you chose to analyze Google AI Studio as one of your case in your group. Later we'll have a group activity to analyze different applications and tools. If you chose this one, you will be encouraged to figure out what those are all means. What is the temperature? What is top P score or top P value? And what is structured output, code execution, all those different tools that you can call, you can use in Google AI Studio, but it's not available for you to use in the chatbot function, in the chatbot interface. So due to all the customizations here, if you set all the different customization, the same value, it will be reproducing the same result every time you enter a same prompt, including the files uploaded there. You are able to reproduce it because you cannot reproduce one due to the random factor in the chatbots, but here you can reproduce your result. And also it is renowned for its longer context in the Google AI Studio because the chatbot kind of sucks in having a longer conversation. The performance is becoming shitty after a long context. But Google AI Studio does not have less of a problem like that. And it's more reliable due to, maybe it's because of API, or it think you are a developer instead of a general user. It assigns you better quality of the model. That's one of the guess. So, however, I want to highlight here, if you are using API, it does not automatically guarantee you the privacy that you may need. If you are still using the free tier, just like you are using the Gemini free tier, you can still use the different thinking level and different models, but you still suffer from the rate limits per day, and also your data is going to be used to train the model, so the data is not stay secure. If you want to overcome that, just like many of you may subscribe but the Gemini.ai, you can enable billing for the Google AI Studio, and I actually would recommend you consider this and stop subscribing the chatbots and instead enable billing for this Google AI Studio, because AI API costs tend to be lower for our institutional research tasks, because we only need to use so much token for regular IR tasks. But if you are a developer, you are intensively exploring and using the Gemini model, that you may anticipate using a lot of token, the subscription might be still better because it's a settled fee. So it's a lot of depending on your different use cases, but for the majority, the API might actually costs lower. If you are very cost sensitive, this would be the advantage. But also the other advantage, as I mentioned, if you want to reproduce your result, if you want to use much more tools, if you want the output to be more reliable and have longer context, etc., even maybe compare with your subscribed version, a paid version on the Google AI Studio might perform better, and you have much more tools to use. So just something for your consideration. And as I already hinted about the privacy concerns, here are a few further thoughts and comments. So if you are a Google campus, my campus is Microsoft campus, but I used to have a Google campus account. So that account, once you log into it, as you may already find out, those free tier usage are still protected, meaning your data is not going to be used to train their model. You can see a shield a shield icon when you are sending a message to the chatbot. That means on Gemini, though, only on Gemini, I think. So that's one way. If you want to stay free, use free AI with privacy issue addressed. That's one strategy. The second one is my personal comments here. I may prefer API access over web interfaces when possible due to the documentation it has. Although I haven't touched on that yet. In a later slide, we will flesh that out. And also API access costs a bit less. API gives you, the interface gives you more reliable and more tools to use. And be mindful, it's the privacy we are concerning here. Be mindful of what you shared, even you are using an API. If you're not paid, it is not private. So if you do need to use, then need to do extra step before you upload anything. So anonymize, aggregate, remove PII information. So those are the considerations. This is such a good transition because we just talked about privacy to transit into this local deployment. So go back to the worksheet, and part 2 of this activity 3, you will find out a section called local LM Studio. So this is a place where you will download a application called LM Studio and then play with it by downloading different open source models. I'll stop here and let you follow the instruction, the 4 steps on the worksheet to play with this local model. And you are free to upload any data there because it's a local model and it has data privacy insured. If you know your computer storage well, you may also start playing with different models. The model I recommended in step 3 of the instruction is a only 1 gigabyte model, which is a very small model because I do not know how many storage you have on your computer. So that's a very small model and the performance might not be the best. So feel free, based on your own case, your own storage, figure out what model you can download. And a larger model usually means a better performance, meaning your prompt may be understood better. You do not think it's stupid, it's smarter. And the output might be closer to what you want, given controlling the same prompt. So you still need to write your prompt carefully. I hope you enjoyed this activity on running LLMs locally, and you may explore some of the ways you can upload the data and test how well it performs. Now I want to move forward a little bit. Now I want to take a pause and see what we have went through by so far. So we had some recap of the 3 approaches, and the most recent demonstration on the API and the local deployment actually involves no coding. So the last version of the API and local deployment, I said a code-based implementation, but nowadays, and actually last year already starting this code-free movement, that you really only need natural language to interact with AI or any technology. So it's being more user-friendly without any technical skill. And also, some of you may already heard the discussion and sometimes rumor about technical skills is dying, and you only need to be a good communicator and a good data auditor, a validation or reviewer to provide validation of the output and to be an expert who knows the context and who can verify with your domain knowledge. So a lot of the movement happens around less of a coding or other technical skill, but more of a verification or a review and human relation kind of skill. So this is also something I invite you to discuss at the end for your comments and thoughts about the future of AI development. But here to get a refresh and the correction of our previously discussed approaches of integrating LLM into IR. And then maybe we've already defined the 4th approach, and it's actually very similar to the integrated AI tool, but in a different level. It is still a LLM integrated tool. It's just a specific tool that is very powerful that we want to make its separate approach called LLM agent. And we have discussed different types of tasks that fit for a chatbot or a API or local deployment versus a multi-step complicated task that is more suitable for a LLM agent to solve. So this is just a midpoint checkpoint so that we are on the same page and we know what we come from, and now we know what we are going to transit into. So we're going to transit into this 4th approach, but it's very similar to this 3rd approach. It's just a very specific and powerful integrated AI tool. Now, talking about this task that I call it multi-step complex task that has a longer workflow that require a actually LLM agent would be a very efficient approach. You can still use a manual approach where you integrate API, you call it every step, but agentic workflow would assist you much more. And the current performance of agency are good enough that will save you a lot of time. This one, the multi-step are chained together systematically by the agency. Then this is what we mean by a full documentation here. You can record and track your prompts for reliability, for a documentation, and reproducibility for a different project by using a very similar workflow type of purpose. And then it's here you need to install some type of agent, and you need to either call a local model or a cloud-based API to use the model in your agent to build your end-to-end workflows. But you are building a workflow. You're not building the agent. Someone already built it for you. Although you can adjust the different infrastructure or the design of the agent, but it's more of a deployment of and using the agent instead of building an agent. So we're not teaching you to build an agent. You only need to know how to use the agent. You need to know how to set up. So here comes to a more technical part. Before we go into the details of how to set up, I want to first define what is LLM agent in terms of what are the available products and agents are there. So previously, in a few slides ago, we defined LLM agent as some AI system that can automatically complete a very complex multi-step workflow using planning, using reasoning, and by calling different tools. Here are the examples and products that's available already on the market, very recent development on the market to help you achieve different type of task. The first very popular task that LLM agent can do is coding agent. I think top 3. There are a few more coding agents, but they are not as popular as these 3. So Claude Code is a coding agent that is based on the most recent Claude Sonnet 3.5, I think, that model. And Cursor is based on sometimes both GPT and Claude. So it's a coding agent that has been top for 2 years even, but very recently Claude Code beat Cursor and became the best, but it's evolving. So we don't know which will be the best, but they both are performing very good. And the less popular but still promising ones are Open Menace that are based on this open source model Llama. That means you can deploy it locally if you have large enough CPU and GPU. So those are the coding agent, and later we're going to show you and demonstrate you if you are interested in developing code using natural language and having the agent writing code for you. So that's the first very classic type. The second type of it would be those agents that can control your computer locally. That's Hermes, very recent development. OpenClaw, it hits the news if some of you are into AI development news in maybe February-ish. It's very popular and also cause a lot of harms. So in the news, it's not only good news, but also dangerous and warning news as well. So because it has the ability to control your computer, you may need to be cautious on OpenClaw, while Hermes might be the middle between a full access, very wild agent and a traditional specific task agent. So ALF OS, I haven't used it before, so that's on the top of the leaderboard for the general purpose that you can deploy it locally and then use it to control your computer type of agent. So this type of agent is not for specific coding or any specific task. It's more of a local control of your computer type of agent. So you can use it to manage your calendar, to send email, to create slides, basically everything and anything you do on your computer. These are the agents you can ask them to do it for you. If you give it to permit it to have full access, it has then full access to, like you do when you are manipulating with different apps on your computer, it has the access to open the apps and to do specific tasks on it. That means it's also you need be cautious on what it can access to and cannot, and set rules monitoring it. It sounds very dangerous, right? We will have time if you're interested in later the case analysis exercise and activity. You can choose one of the agent here to analysis and to understand the dangerous or promising aspect of this. But last type of agent I listed here is management / administrative agent. There are a few that's popular listed on the website, but you can find out other agents on your own. The four I listed here is a task manager called Lindy, a creative writing agent called InkOS, and a tool for both building agent and also manage different tasks called Crew AI. And another is more developer-facing tool that you can use to build multiple agents and to design the agent flow, etc. And that's called Microsoft AutoGen. But that's beyond our scope here to dig deep into each of the feature of those applications. This slide is only meant to inspire you for the different types of agents and different types of tasks it can do for you. And later in your group, you can choose anything that you're interested to dig more into on your own and then share with the larger group for your research. And now it's the time for our another 10-minute break. If you need a break, you can take it. If you do not need a break, feel free to already start the activity 4, which is exploring the different agents or tools or models if you want to dig into them further. So this is the activity which is a group research task for you to investigate anything that you want time to investigate and to discuss with the group. This is the opportunity and the space that we want to foster a community for you to learn by working in group and also share your concerns, questions, and what you find out, what you're still confused about. So this is a point for us to digest all the previously mentioned products and models. I hope it's not overwhelming. And now is the time you take pace in digesting a little bit by working with your group, discussing with your group mates, and together maybe identify one or few, or each of you can be responsible or work in pairs for one or several specific things that interest you most. So now you can either take a break, but later after the break, there's 10 more extra additional minutes for you to complete this task. So you can either use 20 minutes or 20 minutes to complete this task. And you can take break at any time during this 20 minutes. And I also want to walk through the 3 steps here in case it's not clear enough. So step 1 on the worksheet, as you can see, you need to choose one specific AI product or tool or an agent or anything that's mentioned or not mentioned here, but it's something excited, new, or you have experience on it for you. So choose any of them. If it's not in the list, add another row and put in the name of that product. And then in the second row, you need to note down the key points you've learned, you've experienced, you've thought about, you want to share with each other. Here, using the bullet point, and also if you have any resource like an article or a video you want to refer to, you put it in the link and it's inserted in the link. So it's clean enough. Do not paste the raw link because it's messy. And we cannot see the key points anymore. So only put the key points down and in the parentheses, insert that link. And thank you for doing so by making this worksheet readable, because later others may want to review the different other products they are interested in. And the last column, is optional, but if you do have some questions or exploration plans or critiques or any other limitation you want to note down, you can put it down on the third column. I hope that clarifies, and I'll let you spend your 20 minutes now.